Hello guys, welcome back to the channel Mathemagix JEE. This is part of the CBQ series, that is concept building question series, where we are going to solve specific problems to develop our thinking capability for JEE Advanced. So this is the first question of this series. This is CBQ number 1. As always, I would advise you to give an honest attempt to this question before seeing the discussion. Here it says, let C1, C2 be two circles touching each other externally with radius 3 and 4. So let us draw the diagram first. C1 is a circle of radius 3 and C2 is a circle of radius 4. So this is the circle C1 and this is the circle C2, and they are touching each other externally. That means this is the line joining both the centers of the circles, and this is their common tangent. Now it says that C3 be a circle touching C1 and C2 internally at points P and Q respectively. So C3 will be somewhat like this. This circle here, it is C3, and C3 touches C1 internally and also C3 touches C2 internally. This is the point P and this is the point Q. Now the tangents to C3 at P and Q intersects at T. That means if we draw tangents at P and Q to the circle C3, they will intersect at the point T. If the length of TP is 5, then which of the following statements is oblique are correct? So the length of this TP segment is 5. It is given to us. So the center of the circle C3 will be lying somewhere here. So let us denote the center of this circle as O. So here the radius of the circle C3, let us assume that to be R. So this whole line is of length R, and this is a circle of radius 3 and this is a circle of radius 4. So this must be also R. Now if we draw this diagram a little bigger, we get that this is the circle C3 and here is the point T, and this is the point P on the circle C3 and this is the point Q on the circle C3. So PT and QT are tangents to the circle C3. That means by the property of circle we can say that length of TP must be equal to length of TQ, because from any external point to a circle, tangents drawn to the circle have equal length. That means if we connect the center of this circle C3 to the point T, this is the point O, then this line segment should bisect the angle between P, T and Q. So if this angle is theta, then this angle must be also theta. Now here, this is the circle C1. This is of radius 3 and this is the circle C4. Sorry, C2, and this is of radius 4. We drew these circles separately to analyze the given situation. So here is the circle C1 and C3 is touching this circle internally, and also C2 is this and C3 is touching this circle at the point Q internally. So this is part of the circle C3 and this is the part of the circle C3 also. Now we know that by the property of circles and tangents to it, the tangent to a circle is always perpendicular to the radius. So here this angle must be 90 degree. Now if we look at the diagram that was like this, these are two circles C1 and C2. This is 3, this is 4, and this is the circle C3, and this is the point P and this is the point Q. So here if this is the tangent PT and this is the tangent QT, then if we join the center of the circle C1 to the point T, and similarly center of the circle C2 to the point T also, then these are two line segments. Let us say this as M and this as N. So MT and NT are two line segments drawn by us. Now if we name this angle as alpha and name this angle as beta, let's say, then we know that this is a right angle and this is also a right angle. So here this right angle will give us a trigonometric relation, that is tan of alpha is equal to the radius of the circle C1, this is 3, divided by the length of the line segment PT, which is 5. And also if we look here, this triangle will give us tan of this angle beta is equal to the radius of this circle C2, that is 4, divided by the line segment QT. Now we know that from the previous discussion, TP is equal to TQ because they are tangents drawn to a circle from a same point. So this QT segment is also of the length 5. That means tan alpha and tan beta is known to us. Now if here is the center of the circle C3, then we can say that if we extend the line segments PM and QN towards this direction, then they will definitely intersect each other at the point O, which is the center of the circle C3. That means here if we look at the quadrilateral POQT, this is the point T, this is P, this is O, this is Q. So here is 90 degree, 90 degree. Now as OP is equal to OQ, because OP and OQ are the radii of the circle C3, so they must be equal. And PT and QT are also equal in length because they are tangents drawn to the circle C3 from a point T. That means this is nothing but a right angle kite. So here this angle is theta as we discussed, and as this angle bisector passes through the center of C3, that is point O, if we extend the common tangent to the circles C1 and C2 to the point T, then let's say this point is R. So the angle MTR will also be alpha from the same property that we discussed here. Similarly, this angle will also be beta. That means we can get from this diagram that 2 into alpha plus beta is equal to the angle theta plus theta, which is 2 theta. That means theta should be equal to alpha plus beta. Now from this relation, if we apply tan both sides, that means tan theta is equal to tan of alpha plus beta, which means that tan of theta must be, if we apply the formula, it becomes tan alpha plus tan beta divided by 1 minus tan alpha tan beta. and tan alpha and tan beta is already known to us, so this will be equal to 3 by 5 plus 4 by 5 divided by 1 minus 12 by 25. So this comes out to be 35 divided by 13. Now from this diagram, if we look closely, this triangle I am looking at POT triangle. So triangle POT. Triangle POT is like this. This is the point T, this is the point P, this is the point O. So OP is the radius of the circle C3. Let us call this radius as R. And PT length is already known to us. It is of the length 5. And this angle, as we discussed, it is theta. So from this triangle, as this is right angle here, we can say that tan of theta will be R by 5. So that means we get R by 5 equal to tan theta, and tan theta we already calculated as 35 over 13. That means the radius of the circle C3 will be 35 into 5 divided by 13, which comes out to be 175 by 13. Now, this is one of the questions asked to us, the radius of the circle C3. So here the radius of the circle C3 will be 175 by 13. So option A is correct, option B is wrong. Now we need to check option C and option D. In option C and D, both, it says that the radius of the circumcircle of triangle TPQ is this. So we need to check these two options. Now the radius of circumcircle TPQ. Let us draw the diagram again. These are the circles C1 and C2. This is 4, this is 3. And this is the circle touching internally both of them. And here is the intersection of the tangents, the point T. So here TPQ, that means this triangle here. Now here, if we want to draw a circumcircle of this triangle, it will be like this. Now we know by a basic property of circles that the circumcircle of this triangle TPQ will also pass through the center of the circle C3. So this point is center of circle C3, which is the point O. You can also prove this easily because this angle is a right angle here. The OPT angle is right angle. That means the OT should be the diameter of the circumcircle. That means OT will be 2 times the radius of the circumcircle. So we have to calculate the length OT, which is equal to OP square plus PT square and the under root of whole this expression. That means it becomes OP is the radius of the circle C3, which is 175 by 13 and whole square of it. Then PT is of length 5, so 5 square. Now this we can simplify. It becomes 13 in the denominator and then 175 square plus 65 square. Now from these two we can take 5 square common. That means if we extract the 5 square here, we will get a 5 outside the radical sign. That means it will become 5 by 13 into, this will be 35 square plus this will be 13 square. So this will be 5 by 13 under root 35 square. We calculate as it will be 175 and then 105. So 5 2 2 1. So 1225 plus 13 square is 169. So this will become 5 by 13 root under, this will become 1394. So this is the diameter of the circumcircle. So if we calculate the radius of circumcircle, which is the circumradius, it will be half of this value. That means 5 by 26 root under 1394. So this corresponds to option number C. So option C is correct and option D is wrong. That means the correct options for this question will be option A and C. I hope you understood this question.